Hello friends, Happy New Year and welcome back to our channel. It's winter and probably the coldest time of the year, unless you are fortunate enough to chilling in the beach of Hawaii. But even though it's very cold outside and I'm really literally freezing, my friend over here is totally fine. So how cold is cold? This winter, you must be facing some serious challenges on a daily basis. For instance, you have to go to work and you can't because you first have to shovel the driveway and then you have to clean off that ice from your windshield, and then you are obviously late to work and your boss is obviously pissed at you. Or you are in your school and your friends challenged you to lick that cold metal pole and for some reason you decided to do it and now you're just stuck there. Whatever it is, scientists will say that it's still not that cold yet. And compared to your misery, what atoms and molecules are facing every day in our labs are temperatures which is lower than what one would expect in space. That's right, here at QNS we are working at temperatures which is roughly 270 degrees below the freezing point of water. If our body comes in contact with that kind of environment, we will immediately get cold burns. So always remember, safety is the first priority. Now you may want to ask, how can we be so cool? Well, there is a whole separate branch of physics called cryogenics that deals with such things. Already in 1880s, scientists knew that we can reach cold environments by liquefying natural gases such as oxygen, nitrogen, etc. And like this we can reach minus 173 degrees. This was the first time mankind reached this kind of cold temperatures. We can reach further cold environment by liquefying helium gas, and that takes us about minus 270 degrees, and by mixing two different isotopes of helium we can get, so that is helium-3 and helium-4, we can get even colder environments which is minus 273 degrees. Now to appreciate this, we first have to realize that temperature is basically a measure of energy content of any matter. So for example, when the air is hot, molecules tend to move fast and they have higher kinetic energy. On the other hand, the colder the temperature, the smaller their velocity and the lower kinetic energy of the molecules. Finally, at minus 273 degrees, all the motions will freeze out. There is no temperature possible lower than this, and precisely this is why physicists call this as absolute zero. But the whole point of going to lower temperatures is not for better food preservation or to stop Frank from bullying Morty.
What is that supposed to mean?
Rather, we want to learn some interesting physics that is otherwise inaccessible. For example, some materials lose their electrical resistance at such low temperatures, meaning that electrons can flow through the material completely unhindered. And this is called superconductivity. This breakthrough wasn't possible to realize until the realization of low temperatures with liquid helium-4 in 1908. One immediate application of this is the use of superconducting magnet and low temperatures in an MRI machine that we regularly use these days for imaging the affected parts of our body. Anyway, you can just simply use it for making a banana split. That's all for today, friends. We will come back to our channel with many more fun facts. Do let us know if you want to learn about something in particular in the comment section. Subscribe to our channel, and since this is winter, do your best to stay warm and take care.